Let's get started with Kamar, please. Go back. No, that's it. I think that's it. I already talked about the Python.
Thank you. Okay. Test, test. Okay, there we go. All right, so a brief introduction about myself. My name is Mohammad Kamar. Kamar, everybody knows me as Kamar. I'm a senior software engineer at Agoda. I joined here in February. I really want to keep the intro brief, so I like Python, the programming language. I've worked with Python before. Simple, nice, built web servers. I like ThaiPy, the event, the organizers. Everything here is nice, and I like pizza. That's the intro. And the beer. Okay, so today I'm going to be presenting UX versus DX in Python. Now, the title is controversial because wherever I do bring it up to someone, they're like, what's DX? That's not a good title. So maybe it's a bit confusing. So UX is user experience. It's usually used on the front end. However, there's not much criteria that you can test Python on the front end. I mean, we did have a speaker before that presented PyScript. That's one way you can do it. But in this case, we're going to use some other criteria. And DX is developer experience, which is very, very subjective term because what can be good DX for one developer might be very, very bad DX for another developer. But we're going to try to measure it. We're going to put some standards and see how it goes. We start by the chapters. We're going to define them, explore web servers, measuring developer experience, developer preferences. What do you consider in terms of performance? Some case studies for UX and DX, and how do you strike a balance between them, and a conclusion. So starting off, let's define UX and DX. I think we already did a small definition, but to formalize it, UX encompasses overall experience a user has when interacting with a web application. It doesn't actually even necessarily has to be a web application. You can be a data scientist building some CLI application for your clients. You can be any other type of developer, but UX is the experience that the user has with your program. DX refers to the experience of the developers while building, maintaining, and scaling the web application. It affects productivity and job satisfaction. And so oftentimes, if you're working with a framework that you don't like, you're not going to be performing very well. If you're working with a programming language that you don't like, that you don't know, you're not going to be doing very well. This is bad DX. That's why it's, again, a bit subjective. And so a very important point is that improvements in one area often lead to improvements in another. And so if you have a happy team that likes working with the programming language that you're talking about, the framework that you're talking about, they're going to produce, they're going to do much faster development. They're going to have much better tests. There's going to be more motivated. So the improvement, they can do better scalability. If they know the technicality of the programming language, they can have better scalability, better design, better architecture, better security. All of that comes in with the inclusion of developer experience. And so developer experience impacts user experience. We can go to the next slide. And in this case, we can define a web server as a program. Web server sort of is what I do. Again, I can't speak for data scientists, machine learning, and other fields, but I think it's going to be pretty similar. In that case, a web server is a program that's responsible for handling client requests, serving web pages, and interacting with databases in that case. Any program that just takes in requests and sends in responses can be considered a web server. Python is known for having many libraries, and there are many, many, many web server frameworks, packages, libraries, whatever you want to call them. Approaches to building web servers in Python. You can just write a very, very simple application using a built-in module called http.server. It's not going to be that great. We're going to go over it. You can use some asynchronous libraries like AIO-HTTP or FastAPI, or you can go on a full-fledged framework. And some people might argue that FastAPI is a framework, but we'll get into that. Frameworks use the framework-based servers where you can use Flask or Django. So let's start by how do we measure developer experience in web server code? We can put some very loose criteria for everybody, because again, a lot of disagreement, but we can say, hey, if you can set up something easily, relatively easily, you can learn it relatively easily, that's good DX. Code maintainability, if on the long term, you wanna have good code, you wanna have your team organized around that code, you wanna have your team write it well, that's good DX. Debugging, testing capabilities, if it's easier to debug your app, then okay, there you go, that's good DX. Again, these are sort of non-arbitrary standards, but they might change from person to another. So starting off, we can go with HTTP server module. And like when you just go into the HTTP server module on Python website, it'll say, hey, don't use this for production. It's not safe. Just don't use it. But it's pretty nice. You can just say like Python-m run the HTTP server module and specify a port, and you have a web server. Very, very simple. And even like the code for it is relatively simple. You have to create a class. This is going to be a relatively code-heavy talk in comparison to other talks, but I think this is simple enough. You just create a class. You extend the simple HTTP request handler from HTTP server module. You run your server. You say like when you're returning a response, self.response. You set the headers, and then write file.write, and you're returning. And so immediately, again, this is pros and cons of this is that it's a part of the Python standard library. You don't have to install anything to your computer. You can just write it and then again, serve it. It's pretty nice. It's simple and lightweight. It's really lightweight. But it has its cons is that it's very, very, very limited feature. Again, you have to write every single thing manual in this. There are some package inside of it that's pretty nice, but generally it's low level. You don't want to use it. Again, recommended by the official Python documentation. And can become very messy for larger products. We can move on to asynchronous servers in that case. We can start off with both AIO and Fast API. And so I do want to note that for many of these frameworks and libraries, you have people that really love the presentation of the framework. And so if you look at Fast API, they have this very fancy landing page, while AIO HTTP is just literally the doc pages. But I think the explanation for each one of them is pretty good. AIO HTTP is asynchronous HTTP client server for async.io and Python. Okay, it makes you build web servers using async.io, and you have Fast API, which has like definition underneath, which we can't read. We're gonna delve a bit more into AIO HTTP first. So it's a lot less code than the HTTP example. And it's pretty nice. You just import the web library and you can use everything from it. You can define your handler functions to handle responses, requests and responses. If you want to return something, you just say web.response and return it. You start the application by just saying web.run app and the application. We can go over the pros and cons. So AIO HTTP is easy to set up. It's pretty easy. It's nice. All of the following are pretty easy to set up, except for some future spoilers. It's simple asynchronous code, modular design. You can just write the async function here. I was gonna write. It's pretty nice. Debugging with async stack traces. You get some nice stack traces that you can debug through. This is good. Yeah, it's relatively good. Cons is that asynchronous programming is like pretty annoying to learn, especially for different type of developers that don't really use asynchronous libraries. Like Python is single threaded, and so if you're just running some app for machine learning, you're not gonna really need that. And dealing with asynchronous tests can be really hard especially if you define a function as async and then you run it without waiting, then some other line of code runs in before the first one, it gets really confusing. Testing complexity due to asynchronous nature. Also, like you have to define these decorators for your functions. It's just generally not too great to write it. And again, it's pretty minimalistic. It's nice to be minimalistic, but it might be too minimalistic. We can go to Fast API now. I have this motto that don't trust a company's own advertisement because it's just going to give you like only the good stuff about itself. In that case, the fast API documentation says it's fast to code, fewer bugs, intuitive, easy, short, robust, standard-based. And so if you read this as a developer, you're like, this is the best DX ever. This is the best UX. It's going to give us the best performance. It's going to be great to program in. And they give like some statistics where they say it increases the speed to develop a feature by 200 to 300%. You're like, wow, that's pretty nice. It reduces 40% of human developer-induced errors. That's also nice. Now, they do have an asterisk at the end of these sentences. And in here on the small line, I'm not sure if you can see it, they say, estimation based on tests in internal development team building production applications. So it's all like internal stuff. They're going to be using their own metrics. It's not too great, but they have good marketing. It's nice. Fast API is growing very fast. Funny. So we can check some fast API code. Again, I think slides might be a bit far away for some people. But again, defining the route for application, you just say route.get, and then you add it as a decorator. You set the route /get/something. You can just return JSON as is. You get built-in Swagger documentation. Now, for anyone who worked with, who built any scalable application, having Swagger documentation or like Open API documentation is very, very nice. Fast API automatically like builds that for you. It's pretty great. You can just you got this function, you run it with UVcorn, you give it the flag reload, and then when you change the code, it'll reload. Development is nice. If you're writing code and the server underneath is reloading with the changes in your code, it's also very nice. You have immediate feedback for your work. This is good DX. So I have an example also of the tests. Again, this is actually like a better test. We can see if we're asserting this, we're just like assert response.json is this message that we returned there. And that's it. It's very nice. In that case, our assertion will be wrong. I just noticed it's different. Okay. Pros and cons. Pros is very easy to set up. Again, fast API is made to be simple. Like the philosophy of the creator is that, hey, I want to make something simple and actually fast. It uses Python type hints. It gives you automatic API documentation, benefits from standard Python debugging tools if you're using Visual Studio Code to edit. I'm not sure if you can use Jupyter Notebook to edit, but you can use the many tools available in your editor. Cons, learning curve for many modern Python features and libraries. If you want to add anything to this, you're going to have to implement to install the libraries yourself, which isn't great, but still okay. And for many of these, except for HTTP server, most of them, again, are made to be developer friendly. So the cons are not really that bad, but you have to import everything. It's not great. Testing is also not great, but it's easier than the HTTP library. We can go to full-fledged frameworks. In that case, the most two popular ones are Django and Flask. Again, if we trust a company's own advertising, Django makes it easier to build better web applications more quickly and with less code. Now, all frameworks or all libraries or all programs, they're going to use this type of terminology. They say, meet Django. It's, I like the phrasing, ridiculously fast, reassuringly secure, exceedingly scalable. And they have another page on the website that you can say, click more. They have some 10 talking points all in the same language, reassuringly secure. It's exceedingly scalable. It's nice, it's attractive for some people. But if I want to create a Django application for myself, hey, I want to create a web server to return types of cats. Just to create this application, I have to okay, install Django. I get the Django admin as an environment variable that I can use. I can say start project command, and I give it the name of the project. It creates some 10 files. And then one of those files is called manage.py that takes in input. You cd into the directory, you Python manage.py. So run the script that was created here and say start app, and you give it the name of the app. And so it creates an app after you created a project. The application, you have to define your route, and then you define your URL parameter inside of the app. And then you include your application that you just created in the project itself. And so this isn't really that great. I think it's an overkill for a small project. Again, as a developer experience for a newcomer to Python, especially, you're like, what's this? What does this do? What does this do? Why do I have to run this? Why do I have to run this command? What does, no, they mention like MVC a lot. What is model? What is view? What is controller? It's a lot of terms to begin with as a developer. So again, Django is huge in the developer world. It's very, very opinionated, and it comes in with its own admin interface that's very nice. You just like spin up your application, you can have admin interface there. And you can update on it later in development. You get your own ORM, your object relational mapping. If you're interacting with a database, you get these, you can create these models. As an example underneath, I think the font is small, but it makes it easier to interact with databases. It gives you authentication and authorization. You can just create users and user groups and all of those annoying things to create. Again, if you're using any other libraries, you have to create these things manually, and it can be really annoying and can make many, many difficulties, but Django just gives you these out of the box. It gives you form handling, middleware system, URL routing, templating engine, database migration, security features, all of those. It's very nice. Cons is that it's overwhelming. Like, come on, this if you just go into this, it creates so many files. Its opinionated structure might be restrictive. Many developers don't like to work on a pre-built project in a sense. This is just pre-building your project for you. Many developers want to have control over what they write, how they structure their code, how they structure their directories. We have many fights within Agora on like how we want to structure things. I imagine like on the front end world in JavaScript world, for example, you have both also Angular and React, where Angular also gives you a solid structure. It's very opinionated, where React, again, everybody fights on folder structure because of that. So some people just really don't like that Django builds that already. They want to have control. And so again, learning curve is bad DX in a sense, unless again, you later become really good at it, then this is convenient. So we can go to Flask, which has the worst like intro page ever. If you're checking out marketing, this is very bad marketing, Flask people, or like they don't even have an intro. They don't have a catchy sentence. I don't know how am I supposed to program in Flask if I don't have catchy sentence. They just literally take you to the docs page. Welcome to Flask documentation. Get started. It's pretty nice. It's like a middle path. It gives you, it's pretty simple to write. You can just, again, create your Flask application and run it. You can define your route very similar to defining in Fast API. You return a string. That's pretty nice. You run it. You have your template engine, Jinja 2. It's, if you're writing a front end without a framework, you can just use this templating language. It's very convenient. So Flask overall is convenient. It has these tools such as routing, template engine, again, development server, extensions. It's nice to write. We can look at some advanced code here. You can use like libraries such as SQL Alchemy and then connect to a database. All of this is like, it's simple, it's nice, it's moderate. Pros, lightweight, easy setup, flexible, allows structure as developers see fit. Benefits from standard Python debugging. Cons of that, manual setup. Again, you have this push and pull between people that want everything to be built in, such as Django, and people that want to build things themselves, such as Fast API, in this case, Flask. And you'll notice that in both cases, I put it as a con, that for this and for Fast API, it's a con that you don't have everything built in, while for Flask, you don't, or for Django, it's a con that you have things already set up for you. So a bit subjective, you know, we'll continue. It has lack of strict structure, may lead to less maintainable code, especially if you're like building servers for large applications. You will have fights about folder structure. I want to share this result of a developer survey that was done by JetBrains 2022. If you're like checking which frameworks developers prefer to use, you're not gonna find the HP module here or IOH TTP because it's like very small, but you'll find Django, Flask, and Fast API as the top three. I think Fast API, again, is climbing very fast, but these are the most used now. You have a lot more libraries. We're going to see some other examples of some other libraries when you go to performance. But again, in case you're looking for what's being used the most, it's these libraries. Um, so we're moving a bit to the UX. But again, we talked about UX when we talked about, hey, Django and Flask both have this templating language. That's pretty convenient. We can consider it in our UX. But the main criteria that we want to judge UX, that we can judge UX from a web server perspective, is their performance. Now, I went into this talk thinking that there's going to be this huge performance between them that's going to make a huge difference. But it didn't much. We have some spoilers, but we're going to see. We do want to note that the architecture choice significantly impacts. So the two main things that will actually affect your application is your architecture choice and the way you deploy your application. And so you can write code in a very bad, messy way that creates tons and tons of options, objects, lots and lots of work for the garbage collector, lots and lots of, that needs a lot of optimization. This will be very slow. This is one of the most important things in your server that you need to optimize. The way you deploy your code is in Python, you have these two specs for writing web services, WSGI and ASGI. We're going to go into them, but one of them is legacy and one of them is not. And this also makes a huge difference regardless of the framework that you're going to use. If you're using ASGI, it's going to be faster than WSGI. These are the things that actually matter. But when on the same ground, comparing performance of services, let's put some standards on how we're going to compare them. We can compare them according to response time, to handling concurrent requests, to scalability, to throughput, to resource utilization, and etc. We can check, define WSGI, ASGI. If you remember when we went to the Fast API example, we started our Fast API application with UVcorn, the package, and there's like Gunicorn, another package, and UVcorn is like rainbow. That one's green, I'm not sure. And they often do a comparison with like Fast API and Flask because Flask is WSGI based and Fast API is ASGI based. And so we're gonna go over the definition of them. There's also this like funny meme that I found. Everybody's looking at ASGI. Now, WSGI is, again, it's just the standard definition of how to build a web interface that takes in requests, how you define your sockets, how do you define your input. And again, the Gunicorn library for Python actually just works on the WSGI. It's pronounced whiskey, like whiskey, but with a G. It synchronously handles one request at a time. Django and Flask make use of as WSGI, and they were built with WSGI in mind. Now they did add internet integrations. Again, Django actually has some very nice documentation of deploying your application. Sorry, by default, they're WSGI. You can later deploy them into ASGI. It's suitable for applications that don't need to handle real-time features or multiple concurrent connections efficiently. And so you have this old standard that's not really that great, but you can build applications. If you have many requests that are short-lived, then you don't need to do extra work for Flask and Django. For ASGI, asynchronous service server gateway interface, A for asynchronous, it's an evolution of WSGI. They always mention the word, it's a superset. So everything that works in WSGI should be like compatible with ASGI. It can handle multiple requests concurrently. That's an advancement. Again, these are just standards, but UVcorn is written upon the standard of ASGI. And so any application that is run via your UVcorn is going to be able to handle these concurrent requests better than Gunicorn, which cannot. It supports HTTP, HTTP2, and WebSockets. Fast API and async IO are ASGI based. That's why you can use the async function and await without any external libraries. I used to use Tornado a lot, and every time you have to run until complete, you get the event loop manually. It's just not great. If you're using UVcorn, I think you can just right off the bat. It's excellent for handling real-time data, WebSockets, long-lived connection, and multiple concurrent client requests. So before we get into the meat of the performance, I do want to mention, for some reason, I couldn't find like Flask with the performance websites that I found. So quick comparison between Django and Flask. I found these statistics. The red line is Flask, while the blue line is Django. In this case, they're making requests into a database. The first example, they're doing 10,000 requests. You can see they compare the predefined data with the nested iterations, count, list from database, pagination, aggregation, create, save, update. It is like faster, but it's not too much faster. Like they're within the same range. It's like 1.5x faster. So it's acceptable. But when we are gonna look at the Django performance table, we can just remember that Flask is within this range. So we can go to, I found a website called Methodic, which does these tests. We can find a lot of results with a lot of tests. So the first test is, they did have a note that almost all of these frameworks are ASGI compatible. AIO, HTTP, Tornado are exceptions on the moment. I'm not sure about that because like they have it listed. Maybe they just didn't run it. But the first test they do a test about accepting a request and returning HTML response with custom dynamic header. So you're just modifying the header. The test simulates just a single HTML response. They do a sorting, and most of the libraries there are just unknown libraries, which I didn't know existed. So you have like Black Sheep and Muffin and Sanic and Falcon. Okay, we know some of them, but a lot of them are just not that popular, but they're very, very fast. So while Black Sheep can handle 18,546 requests per second, Django can handle 1,000, which is really not great. So the most popular library is not that great. Again, if we take into consideration that Flask is in the same ballpark, then there you go. We do have AIO, HTTP, and Fast API. It's, like maybe half performance. Mentionable, it's okay. We do have another criteria. We can check how fast they parse path parameters, query strings, JSON body, and how fast they return the JSON response. We have a similar rating, in this case, like Sanic. I just love the name Sanic because it's fast. Is in the first place. Same, yada, yada. Django is really slow. Like again, 800 versus 10,000 is just really not good. Fast API comes in with around 6,000, AIO HTTP 4,400. There's like many more charts, but the combined results are just the following. We have our favorite libraries at the bottom, which is disappointing, but life is disappointing. I found another website called Tech Empower. They did also a group of tests. The first test that we're gonna check is, by the way, these are like, can be considered as criteria to just test your website. If you build a server in any language, you can do these tests. These are, usually I have like, you just create an echo server, you do load testing, or you do like concurrency, how many concurrent requests you can handle at the same time. These are just good criteria in case anyone wants to test their performance. Let's go back. So in this case, there's the test. The framework responds with the simplest of responses, just returns hello world, random non-plain text. HTTP pipeline is enabled, so you can send more than like one request. And if we check the results, so the first chart is the number of requests, like lots and lots of requests. The second chart is latency. So the first chart, the higher it is, the better. The second chart, the higher it is, the worst. And so we have our beloved Django like doing horrible, and again, in both tables. I did only select Fast API, Django, and AIO HTTP, and Flask, but again, I'm not sure why I didn't find Flask. In both cases, like we can see that the fastest is Fast API with running it with Socketify, but we can find like Fast API with Hypercorn, which is like Gunnicorn. It's just not that great. So if you're running Fast API with a library that's not designed with the ASGI standard, then it's just not going to be performing very well. Django is not great when it comes to performance. Again, Django is in the last. This is very, very surprising results when I saw them, but I triple checked. They're very scientific about their queries. So this is what we have. Again, very slow stuff. Different graph, and this one we just parsing JSON, fetching multiple rows from simple database, and then we get JSON response. We run it on many, many queries. Same thing, fast API with the Unicorn, fastest, Django, slowest, latency, fast API, best latency, Django, worst. So fast API is actually like pretty fast, faster than Sonic now. Case studies, we sort of end with our UX and DX comparison. We can check some stories about some people that changed from a popular framework to another. Maybe we can learn something. We have Pinterest switch from Django to Flask. So they removed Django as their code base extended, and they found that they were restricted by the structure that Django had. They switched, they didn't really like using Django's ORM. ORMs are, again, a hated topic. Some people really like ORMs. You don't want to write SQL. You just define it as an object. It's pretty nice. Some people really don't like ORMs because your ORMs can be inefficient. You're not directly interacting with your database. So they didn't like that. Again, as we mentioned, Django comes with its own ORM. They had like a database service for managing database calls. Flask provided a more straightforward platform to build and expand APIs. They just like Flask. It's simpler. They wanted to define their own stuff. Found Flask to be more flexible with custom code. Django proved great for fast implementation due to its comprehensive feature set, but was limiting when custom solutions were needed. So in this case, again, Pinterest, I imagine, has a big engineering team. They want to define their own stuff, so they just move to Fast API. We have the complete opposite in this case. There's a website called G Adventures. It's like Agora or Kayak or any of these like websites that you can book activities. Very similar scenario. They moved from Flask to Django in this case, where they said, we chose Flask initially, but the API built with Flask, the API built with Flask could transform a single request to multiple source system requests. It was pretty nice. Advancements led to increased complexities, however. They couldn't handle all of those, like class explosion or function explosion in that case. Including they didn't want to write their own auth. They didn't want to write their own admin. They probably didn't write other stuff. So just saw an increase in technical depth. They considered all of these things that they had to write, or maybe they wrote and then they didn't have the manpower to update them. They considered them as technical debt. And so they just moved to Django in that case because it comes built in. The flexible nature of, in that case, it's Django DRF, Django REST framework allowed the customization, enabling them to keep their old URL structure. Now, if you remember, like in Django, if we go back real quick, although that was considered a disadvantage, but having to define URLs for your application and for your projects in two separate places, you can have good separation of concerns. That's pretty nice. If you're migrating an existing applications, you just detect your URLs and you put them in one place. So they like that. The flexible nature, we just read that. Moving to DRF helped G Adventures reduce redundancies, keep the API layer simple and better, and manage their backends. That's another example. And the final example, we're not going to read too much into it, but this is the creator of Fast API himself, Sebastian Montano. And he has like a huge guide about how they migrated their application from Fast to Fast API and how amazing it was and how fast API it was. Again, you can take the creator of a framework's word for reference, but if anyone is migrating their applications, you can read, like, he has a two-part blog article. It's very nice. And I have some like example code for building stuff with each framework. Some of them is pretty nice. Fast API code is nice. But we can go to the conclusion. So the conclusion of this talk, what to choose. Uh, so, okay, what to choose for the framework? Check your use case. If you're building a large application, maybe you need Django. If you're building a small application, then take Flask or Fast API. Don't take Django. It's not recommended. Larger use cases, are you an opinionated person? Do you like the predefined nature of an application? You like to have everything set up. You have your models in one place, your views in one place. You don't want to move from a defined structure that you already know that works. You go with Django. You're non-opinionated. You like to build things yourself. Flask. Minimalist and don't like to touch a lot of grass. You like to write everything, then just write AOHTTP and try out different stuff and see what you like. And that's it. Thank you.
Thank you very much. Do we have any questions for Kamal around web frameworks? Yes.
I imagine your metrics with Django and Flask and the others was just HTML responses, right? That wasn't even when querying a database or something in the background, which might infinitely.
They did have actually they were querying the database. So in the second one, they had queries to the database process fetching multiple rows from a single database table and serializing those rows into JSON response. So yeah. And maybe, again, we did mention ORMs before. It's not 20, they have but they see 20 at a time, but the metrics, I'm not sure, I can't find them. But they did mention ORMs, and ORMs can be a big issue. Like they have this N+1 problem. If you're not writing your own queries to your database, you don't know what your ORM is going to be doing. You can just write a join statement, send it to your database. The database will be very optimal. If you write an ORM, your ORM might be doing many queries to the database to achieve what you can just do in a join. So I assume that's the case of what happened here with them. Maybe it's just an unfair test, but these are the ones that I could find that were thorough enough to have everything included.
Any other question? Oh, two more questions.
If I look at these three cases from you, I have the feeling this first discussion we had in the beginning with architecture doesn't matter so much, because in these three cases, these companies changed from one framework to another. It was, I guess, also quite a lot of work, right? So does it really matter, the architecture, when you want to go really fast and then in the middle maybe realize, okay, one framework doesn't work, let's switch to the other framework? What is your opinion on this one?
Yeah, so usually regarding this conversation, I've seen it happen many times that companies change languages, not so much frameworks, because again, if we go back to the comparison with Flask and Django, again, it's like 1.5 times faster, which is nice, but it's not that nice. The conversation that I usually see is people moving from a TypeScript server or a Python server to a Rust server, which is like much more efficient. In these cases, when it comes to Python, if I were to write an application, I would just write it in Fast API. It's simple enough. It's actually fast. You can write asynchronous code. I did mention like the WSGI, ASGI. You don't have to worry about that with Fast API. Just write that application. It's fast. It's not as fast as another programming language. And so if you are going to be moving fast, you want something easy to write and then optimize for performance later, you just start with one of these. Thank you.
Which framework is ChatGPT the best at writing code in?
I'm not really sure. I mean, you'd assume that ChatGPT. Okay, go ahead, please. Huh? Yeah, there you go. So the more material you have on a framework or applying a programming language, like we had a friend of mine here that would write in a very ancient programming language, and ChatGPT would just hallucinate all over the place because it has no idea what's going on because it doesn't have documentation on this. And so the most popular frameworks are going to be the ones that have the most documentations because have the most blog articles, the most information overall over them. And that's it. Thank you.
Anybody else? Ooh, two more, three more. Don't stop.
No, I mean, I showed it in other slides.
Oh, you had a question. I'm coming. Hold on.
Hi, related to what you said, that most companies maybe switch from Python to Rust. A lot of your benchmarks, actually, for example, Black Sheep is very fast because the JSON code is written in Python, so it's much faster. And Scenic is faster because it's using a faster JSON implementation than the standard JSON model from Python.
Yes.
So, and at the same time, Django is also very slow because it has a lot of middleware. In FastAPI, if you start adding a lot of middleware, it's also going to become slower and slower. So it's not really a question. I agree with basically everything, but I think we should take the benchmarks with a lot of salt.
Yep,
Yeah.
yep, yep. I think this is like one of the main points of this talk is that final conclusion is just try things out yourself. I would like to test these frameworks like on a low node instance myself and see how they perform. And maybe when it comes to JSON serialization and deserialization, again, just check how CPython performs. But that's a topic for another day. But well noted, you might find Python to be a lot faster for your use case than other programming languages.
Come on, one more question here.
Yes.
What you were saying about ORM being, okay, it's inevitably going to be slower, but like Django, for example, won't. It discourages you from just executing raw SQL queries. That just got me thinking, is one of them more secure? Is Django? I mean, Django seems a lot slower, but is like the actual kind of out of the box kind of security of it more just better? It better for big companies. Is that why it's so popular? What do you think?
I mean, maybe it's better for smaller companies because if you're a big company, you can have a complete team only for authorization, only for user access, you can have a team for every one of these. But if I'm working on a server myself and I need all of these, maybe I will consider Django for that. You had 2 points. If I were a big company, that was the first point. Oh. Yeah, I mean, you could say so. As he mentioned, like for Django to run, you have all of these middleware, all of these layers to go through. So for a basic server, it is going to be slower, but perhaps eventually it's going to be better for security. Yes.
All right, I think we're going to wrap it here because we have one more lightning talk, 5 minutes by Alexander, who's here. All right, thank you very much, Kamar, for your presentation. Thank you.